Hello, my name is Peter Keene, and I'm an industrial engineer and an employee at Boltabout. And
I am Caitlin Thomas, and I am a mechanical engineering student here at Cal Poly.
And we're going to be doing our project on the design of a Boltabout operation plan.
Today we're going to talk to you about the background of our project, a little bit about Boltabout and the situations that they have going on, and how that boiled down to our problem statement. After our problem statement, we decided to do some research and figure out what would be best to approach. And so we'll discuss our objectives about what we plan to solve in this report. And then our lit review, which is our background research to support what might be our solutions, and finally our solution strategy.
So a little bit of background on Boltabout. Boltabout leases electric bicycles on a monthly basis, and they're a young company, and they're quickly growing. They're based in San Luis Obispo, about 6 months old. And to give an idea of the scale that they're at, right now they have 58 bikes that are currently leased to customers and 94 bikes in total under their fleet. Typical operations at Boltabout include bike assembly, maintenance, inspections, and leases. And Boltabout recently just expanded to a new warehouse where they will be storing their bikes and doing most of those processes that I just stated.
Based on our research and discussion with Boltabout and their operations team, we've decided that the problem that we have to solve is Boltabout's current operations are not fit to meet their growing demand.
So our objectives for the project are to first design improvements for all the major processes at Boltabout, and that includes the assembly, rental, inspection, and maintenance processes. And once we design improvements, we're going to develop standard operating procedures for all of those processes. We're also going to design an inventory management system to help Boltabout know when and how much inventory to buy.
And finally, what I'll be focusing on with my mechanical engineering background is the hardware for an asset tracking system, as well as a facility layout and the storage hardware required for storing all the bikes.
So for our lit review, we looked at some literature on inventory, specifically involving economic order quantity. So we wanted to use this formula to help with the inventory management system, but the traditional EOQ model has some assumptions that aren't very realistic for our case. So we looked at a couple articles talking about different variations of the traditional EOQ model. And one of those was the EOQ model for imperfect quality. So this is relevant to Boltabout because some of the bikes that come are defective, about 5% so far. So it's important to take that into account when ordering. Also, the EOQ model gets changed when you're leasing your assets rather than selling them.
And I looked at options for durable radio frequency identification tags, or RFID tags, options that might work well in the outdoor environments that Boltabout's assets are in. I also looked at one case study of a bike rental shop that used RFID tagging by putting a tag both on the bike and in a card that the rider would carry with them. And the rider and the bike would pass through gates during the check-in and check-out processes, and it would automatically record which rider took which bike and record it to the database.
For the process improvement part of our project, we looked at a couple articles. One involves risk reduction and quality control. This is really important for Boltabout because any breaches in quality control could result in serious injury or even possibly death for a customer of Boltabout. We also looked at when and how to use standard operating procedures to determine whether it's appropriate to do for our project and how to go about doing them if it is appropriate.
Finally, for facilities and storage, I looked at a case study of bike manufacturer Trek. In order to improve their efficiency on their manufacturing line, they designed custom portable racks that helped them. They could load the racks in the material prep area and bring the rack straight over to the assembly line to minimize packaging and time. Another source that I found was of flexible use in interior building spaces in congested construction sites. In construction sites, material handling and storage happens in stages depending upon the materials that come for the different stages of construction. And while the inside of the building is still a shell or it's empty, it can be utilized for the storage and material handling area and be utilized for different places. This might be applicable for Boltabout because they'll have limited space, and during different stages of assembly and operations, the space should function in different ways. So this would be a good reference.
For our solution strategy, we're going to use process improvement fundamentals to improve all the processes. We'll also use simulation to compare alternative facility designs and process designs within the warehouse. We'll use facilities planning and design to determine the optimal warehouse layout. We'll use operations research, specifically the EOQ, economic order quantity model, to help with designing an inventory management system. We'll use engineering test design and analysis to compare alternative methods within a process. So we'll be taking time studies of the current process and tasks within them, as well as alternative methods, and run some tests to see which one actually performs better. We'll also be using human factors engineering, especially with the facility design, to minimize the risk for employees and to minimize the fatigue that they'll experience in a regular workday.
We're excited for what this project has to offer for next quarter, and thank you for your time.